So this talk is quite different from other talks that I've given in the past. My slides are basically just in the terminal. It's going to be very much sort of show and tell. And it is for you guys to ask questions all the time about all the questions that you have about Git. Git is a tool that's extremely powerful and at the same time very much unfriendly to its users. Its primary UI is just the terminal. There's a C library that you can use as well. Hope none of you use that. The Rust bindings for it is actually fairly good. But there's just like so many commands that change behavior completely based on a single flag that's like one letter. Like checkout and checkout-b are completely different. So the audience of this talk is sort of intermediate Git users, like people who use Git every day, but maybe not quite know what all the things mean. So it is to sort of get an understanding of more of like the sort of how Git thinks, and hopefully you'll start to like see patterns and start to understand things better, and just in general be less afraid when using Git. Is there anyone here who has no idea what Git is or has never used it? That's amazing. And the audience is also people who are not afraid of using the terminal. I live in the terminal basically all day. I don't believe in Git GUIs. That's a whole separate topic. So everything that I show will be from the terminal. There's Johnny. Sorry, guys. I would consider these to be like the basic Git commands. If you know these, you can get your work done every day. I'm not sharing.
Let me know if you need some code review on this.
We don't. We don't. Thank you. There you go. Can you see now? Git status, add, commit, push, pull, branch, checkout. Fun fact, checkout can be used to both move to a branch or create a branch. If you do checkout foo, switch to a branch called foo. If you do checkout -b foo, it will create the foo branch if it's not there. It's really confusing. Checkout can also like undo changes to a file, which is really weird. It has nothing to do with branches. So in Git, in a recent version, they've actually added 2 new commands. You can do git switch to change between branches, and you can do git restore to just restore files. So they basically took the checkout command and broke it into 2.
And you can't do git checkout anymore. So
you can still do it, like it's backwards compatible, but you can use these commands as well. Like if I'm on staging, I can do git switch master. And now I'm on master.
That's nice. Can you do git switch -b?
I don't know.
What?
Nope. You can do -c to create, which I guess makes more sense.
It's not much better than
What if you do git checkout b on a branch that already exists?
I think it just goes there.
Yeah, so
Really?
I think so as well.
Check out the master.
Yeah.
No, it doesn't. It tells you that it's already there and it does nothing.
It's a fake.
Thank you.
Remember that.
And merge. Are there any questions? Like, is there someone who's not seen any of these commands before? Like, I've never seen merge. What does it do? All right, we're set. The first thing I want to talk about is when you live in the terminal all day, I think it's a good investment to customize your prompt. And your prompt is basically what appears like before you type stuff. I have I've written a little Rust tool that will like find the current directory, and then it'll print the name of that folder, walk 1 level up, and then print the shortest unique name. So it could print just M, but in the parent directory, I have both a folder called minor and major. So just writing M is not unique because there's 2 that start with M. So they find 1 more letter and it does that all the way up. That was just a fun Sunday project for me. The interesting bit is this one. That's also a Rust script that I wrote. Your prompt is basically just commands that your shell, your terminal environment will run for you before you type anything, basically. I think it's called like git prompt or something. Yeah, so it's just a command that prints that stuff. So it prints the current branch I'm on, and it also prints the sort of ID of the current commit. And I find that super useful if I'm doing like a series of merges and rebases, and suddenly I'm just in a broken state. Like I fucked something up, I need to go back. And I can just scroll up in my terminal and be like, oh yeah, I just want to go back to here, copy that ID and git reset hard back to that. I use that all day because I rebase and merge a lot and I fuck up things a lot. So that's sort of a safety thing for you. You don't need that. I'm going to show you a command later that you can use to undo all your mistakes, but this is sort of a nice safety thing to have. It also, if I try to, so I use like tons of aliases. An alias is like a config thing you can have for your terminal. So that instead of typing bundle exec rails db migrate reset, I can just say rrm.
How do you remember that?
In my terminal. I don't, like I have plenty here that I never use anymore. But I'm very sort of quick at just making more aliases. Like as soon as there's a command that I've typed twice, usually there's an alias for it. And as you can see, like I have tons of Git stuff, and I never use the full Git commands because I just get tired of typing stuff. So like
I did what I did today, Node.
yeah, we used to have daily stand-ups where we would like tell what we did during the day. So I wrote a script that would like parse the Git log and tell me what I did that day because I could never remember. So that was super easy. So GRH is just git reset hard, and I have tons of those. I'll try not to use them because they might not be super obvious what they mean. So if suddenly I type GCO and you have no idea what that means, just yell at me. All right. Yeah, so if I git merge staging, that does not blow up. Now we can just undo that merge by resetting hard there. Let's see, git rails master. So git merge, boom. Yeah, so now I did a merge, and there's a conflict, and it shows in my prompt. So it sort of shows if you have a merge or a rebase that's in progress. I really like that. Because sometimes you just do a bunch of stuff and you forget, I actually have dirty file. Like there's files that I've changed in my repo, I just didn't realize, and now I accidentally committed them. And I have like mnemonics for what the pound sign, and there's a question mark as well. I think it means like when there's like changed files or files that are new but not in Git yet, and I'm not quite sure what the pound sign is. But this basically tells me that like there is stuff going on. So if you want to steal that, it is on my GitHub. Git front. This is a Rust script that you can install. And it was sort of an experiment for me to try to use the Git wrappers for the Rust C library, which is actually a fun little project. And you can Google how to set that up depending on if you use Bash or Set Shell or whatever you use. Yeah. Any questions so far? Great. I think probably the most important command to understand how Git works is git log. Like this tells you, this is sort of why you use Git. So you can see changes over time. You can reset if something goes wrong. And you could be like, git blame on this piece of code. What idiot wrote this? It's actually me 6 months ago. Why did I do that? Hopefully it's there in the commit message. But the default log command, I personally find is super not useful at all. It's just way too much information. And it also doesn't sort of tell you how Git actually works. So if you've done any sort of computer science, you've probably heard of like binary trees and graphs. And that's how Git stores your repository. There's always like a root node, so like the first commit. And then if you make a branch from there, or if you make a new commit, then there's like a child of that first commit. And then if you make another commit, there's a new child. So Git is sort of a graph. And whenever you make a branch, then they split, and when you merge, they come back in. But there's no way for you to see that in the log command. However, I have in my dot files.
In the GUI you could see it.
Yeah, but you don't need to use a GUI. You can do this. So if you do git log graph, it gives you the graph on the side, so you can actually see the tree. And then if you say decorate means that it will print what Git calls decorations. Decorate. It'll tell you if some origin branch is here and where master is, so you get that sort of overview. And if you then also do one line, then it skips all this other stuff. One line, and then you get like a very nice condensed view like this. And then you can say -20, for example, to get the 20 most recent ones. And that's what I have as GL. That just gives me that GLL to show me the whole graph. So here you can actually see this sort of tree structure that I was talking about before, where you have one commit that has 2 children. You can see all the children there, and then they fork, and then they do all that. I don't usually look at this graph a whole lot, but it is a good indicator of where things came from. Also, if you see like lots of stars and then suddenly a line coming all the way from the bottom, that tells you that something has been worked on separately for a long time, and that like master was far by lots of commits, and then suddenly you merged. You can imagine if you did like an upgrade from Rails 5 to Rails 6, that's not the thing you just do in half an hour. That can take a week, but there's stuff happening on master at the same time. So this can sort of give you a visualization of that. But I don't look at it a whole lot. I mostly think it's interesting to learn to sort of understand how Git works, to know what is a child, what's a parent, what's the merge look like. So you can just sort of scroll through and you can see that there's some parts where there's lots of stuff going on. There's some parts where it's fairly thin. If you go really far down, it goes totally crazy.
What should we do?
Yeah, here, I have no idea what we did here. I think we fucked up. I don't think it's supposed to look like
you
this.
asked about interview stuff.
Yeah, that's some Esbjørn commits.
Crazy.
But if you look at this view for like Git itself, Git is of course.
Hey, Johnny's like, just
I
right.
think or something will work on this, or it's the article string or something. But if you look at this view for like Git itself, it just doesn't fit on the screen because there's just too many branches, too many people working on it.
That looks like the entire company.
Yeah. And the graph is also important once we get to rebases, which we'll talk about later. So if you normally just use the normal Git log, I recommend that you set this up. If you want to know the information for a full commit, there's a command git show. It just shows the diff and the commit as well, the commit message for a single commit. So you don't lose the ability to get at the actual commit message. Yeah, there's a Ruby gem called git smart that has a command, I think it's smart log. That's because I'm not even getting git smart
I
log.
use that.
It looks fairly similar. And then you don't need to set it up in your terminal, which is a bit easier. It also prints like who made the commit and when it was made and stuff like that. Git smart. Any questions? All right. Undoing mistakes. One of the sort of common things that I hear in Git, when people talk about Git, is that they're afraid of breaking stuff. And that's not a fear that you need to have, because you cannot break stuff. It is impossible. You cannot lose commits. You can force push, you can rebase, you can reset all you want. You can never lose things. So we're on
I've done stuff before.
We're on, as soon as something is committed and is in Git, it can never be lost. So this is the actual API project. Let's just reset hard back to here. Git reset hard, boom. Now the graph looks slightly different. You can see this is sort of the head. And there's all this stuff in front that is sort of lost now. But Git doesn't care. If we open the Git folder, if we look at refs, heads, master. All master is a pointer. Branches are not special. A branch is just a pointer to a commit with a certain ID. So that we can just change that ID. Like Git, when you make a branch, it doesn't like copy and create a new folder with that code inside it and later merges it. It's all in the same sort of object database on file, and then it just stores where the different branches are pointing to. So that means that if we go up in the terminal here before we did the reset, let's see, so we reset here, that means it's this commit, we can just git reset hard back, and that just moves what master points to, and now we're back where we were before. Which means that we can never lose things, because you can always just reset back.
What if you don't remember the pointer to where you were before?
So git log shows you the sort of parents of your current commit, but it doesn't show you where you've been. There's a command called git reflog, which does the opposite. So this shows you all the places where head, which is what git calls you, like that's where you've been, and all the sort of changes that have happened. So every time you check out a branch, you move to a different commit, that's an entry in the ref log. If you do a rebase and it sort of checks out each commit, that's also an entry in the ref log. So if you're ever like, if you reset hard and you quit your terminal and that commit ID is gone, you cannot see it in the log, it will be in the ref log. And the ref log is like really long. I don't even know, it's 1,000 things. And there's probably a command to get even more history.
Is it the same when deleting? If you delete a branch?
Yeah, because branches are not special. Branches are just labels. So if I create a branch foobar,
it will be found in the ref log.
yes. Let's
So please,
give branch delete foobar. I will create it again. Let's just go to readme. Code. Commit. Add more code. And we'll go back to master. So in git checkout, you can say git checkout dash, and just goes back to where you were before. CD does the same. If I cd into my home directory and I do cd back, I just get back to where I was. It's useful. So now foobar is one commit ahead of master. Master's down here, foobar's up here. We go back to master. If I try to delete foobar, git is going to tell me you can't do that because it's not fully merged. If you really want to do it, you can do dash capital G. So let's do that. So now it's gone. It's not in our list of branches anymore. And let's say that we like quit the terminal. I have no idea. Where did it go? Git reflog. So here I can see that I did check out moving from foobar to master, moving foobar to master. Here's a commit. Commit add more code. That's probably the one I want. Let's make sure. Git show. Seems about right. I can then create a foobar2 branch, and I can git reset hard, which remember all git reset hard does is update what the branch points to. So I'm just moving it to a different commit. And if we look at the graph, now we're back where we were. Add more code. But you cannot lose things.
Well, imagine you had 5 commits. Is it always, if you take the latest one, does it always include the previous commit as well?
Yes. Because this is actually the full name of the commit. It's
okay.
like a SHA-1 or something.
Yes.
And the genius thing in Git is that the ID is a hash of the contents of the commit, who made it, when it was made, and the commit message, and the SHA of the parent. Which means that if you change one of the commits here, it will necessarily change all the commit IDs above. So yes, that will just work automatically.
oh, so are you asking you working on
It's like
something?
blockchain.
It is exactly, it's a blockchain. It totally is.
No, yeah, it was more because it should be stored from a single commit, but that automatically knows the previous kills or related to the commit.
And what if you set to that commit, but now other people have been working and been pushing up? Would you have to merge all the new ones into your one, or does it automatically?
I can do git push -f and just force push it up. But if there is another branch on like the origin or GitHub remote called foobar, then that would conflict. You have to resolve that conflict somehow.
Okay.
Probably just create a new branch, because if you're working on separate things and you happen to have to use the same branch name, probably something that you misunderstood there.
Okay, cool.
So it's not possible to delete. What if I added a token to my Git history? that I pushed it to GitHub.
I can feel that you've done this before.
I would really like it to not be in my Git history anymore.
Yeah, so that's the point. Like if you have a commit like really far away, like all the way down here, and we git reset hard that, so now foobar is way back in time. Like, so if I have like some super secret API token in here that I made a new commit to remove, like it's still in the history. People can still find it. They can find it on GitHub. There are, I think you did that once. And there are tools to like find it and then automatically update all the commits through the history. I believe you found one such tool, right? But again, like that changes all the commit IDs. So at that point, you'll have to force push if you've pushed it before. Fun fact: I have actually done the same thing by accident with my with an AWS secret and key. And a week later, I got a bill from Amazon for $10,000 because there's just people who crawl GitHub looking for those tokens all the time. And I wrote to Amazon, I was like, I fucked up, help me! And like eventually they canceled the whole bill. So that was very lucky. I believe GitHub is actually working on or have introduced a feature where it will tell you if you accidentally commit something that looks like an API.
Yeah, they already do.
They already do?
Yeah.
That's really cool. So let's just get foobar back to where we were before.
Saved my life.
So we've looked at reset hard, we've looked at reflog, let's look at commit amend.
My favorite tool.
So let's push this branch up to GitHub.
That's a really bad sign.
By default, Git doesn't let you just push a branch to GitHub. It tells you to like push it and then set up some origin thing. I have an alias for that, GPP. So let's say that we've pushed this and I'm like, ah, fuck, I forgot something. So you want to add it, go into the README, and let's say this is more code. Add even more code. So now, fuck, I wish these two were the same commits. Often I will push some Ruby code and then Rubocop or like linter will yell at me like, you have to use a blank line between methods. That doesn't make sense to add as a whole separate commit. Then the commit messages also get fucked up and you get those linked commits all the time. So what you can do is you can say git commit -- amend, and Git will let you open the, like edit the commit, and if you have made changes, let's add even more code. Git add everything, and then git commit. Notice now the ID of the commit is 4AF. Amend. Now we'll just add the changes that I made to the current commit. And then I save. Now it has a different ID, CEB. And that's because the commit ID is a hash that includes the changes that you made.
Can you show the lab?
So you will see now that the 4AF commit is gone. There's only the CEB, because those, like, this commit sort of has two children. It has this one and the original one that we made before, if that makes sense. But there's no path from...
You can't lose code, but you can remove commits in that way.
No, you cannot remove commits either.
Isn't it gone, the log?
Well, yeah, as like there's no way, sort of no direct line from this commit to where it was before. But like we can just reset hard back to it. That's totally fine.
Oh, okay, so it's still, oh, okay.
Is it like a, it's kind of like a,
It's very kind of truncated version of this period.
All you can do in Git is add commits. You can never remove commits.
Does the amend work with older commits as well, or is it only the latest one?
It's only the latest one. Other than you have to use what's called interactive rebase, which I will show you later. That's where the superpowers are.
Okay, one question regarding this.
Yeah.
So you say you use this git commit amend command when you want to add some linting changes after you push together.
Yeah.
What if I'm working on a branch and I push something together, and then immediately when I push cat pause, my code, and then I amend my commit locally and push that commit to GitHub. So that like I'm pushing the same commit twice.
Then you have to force push.
Okay. But then what when Cat pulls it?
Then she will. I'm not exactly
Force
sure,
pull?
but she'll get like weird error messages. Like
Yes.
I cannot, from where I am, I cannot directly update to where the like remote branch is.
No.
Usually in the backend team, at least, we don't work on the same branch at the same time. Usually I work on my branch. When I'm done, I submit a PR.
Okay.
If there's any improvements, I do those. Otherwise, you end up in these kinds of situations.
So, yeah. Before I've seen that there's just like a rule that if something has been pushed to GitHub or like pushed, you cannot change. You don't change it.
Yeah, that's a limitation that you can choose to have yourself. If you have multiple people committing to the same branch, if you do that, you will have like merge conflicts and stuff anyway. So I don't think that's a great workflow to have.
But in general, I think you should avoid using amend if you're multiple people working on the same branch.
Yes.
Yeah, I would never amend a commit that was on master. I would never force push master. That's just asking for trouble.
I sometimes amend to rename to edit what I wrote in the commit message.
Yeah, but that also changes the ID, so you have the same problem.
Yes, but before I push it, I never do it if I push it to GitHub.
Oh, that's fine.
So like we can push this, but if we then make changes, and we I have git amend, of course. Now if I push, fuck, I accidentally force pushed. But had I run the normal git push, it would have complained. Let's say, let's go back here.
It's so easy to force push it when you are.
So now I force pushed where I was before. Let's double check and check the read. Yeah, so those changes are not there. Then we'll reset here. Now the changes are there. And then if I just do git push, it should yell at me. Yeah. And then I'm like, just force push. GitHub has a setting where you can customize, like it won't allow force pushes to master. It's probably a good idea to turn on. I don't think we have it turned on in the backend. We do force push to staging sometimes when we like nuke the staging branch and recreate it from master. Then we force push, especially to the row. But force pushing to staging to master is definitely always a bad idea. So yeah, the important part to understand is that you can never remove commits. Even if you make a branch, you do some work on it, you go back to master, you delete a branch. If you wait like a year, those commits are still there in the ref log.
Do you know how this is stored? I thought Git used deltas. That sounds like it's going to use.
I think they do actually. Really? Yeah, I'm not exactly sure how. Git also only stores the contents of the files. They don't store like folders. Like if you have an empty folder, Git can't see it because there's no content in there, which is interesting. All right, rebase. This is the interesting stuff. So the difference between a merge and a rebase is how the graph looks at the end. The resulting code will be the same, but the representation in the history is what is different. If you take, I don't know exactly how Git does it, but when you merge, it takes like the changes from one branch and the changes from another and sort of combines them. I don't know the exact algorithm, but you can customize that and tell Git which algorithm to use. And when you do that, you'll get what's called a merge bubble or a merge commit. So there was some work down here, and there's 3 commits here, and they both, you can see on the train tracks, they come together, and then you have this commit that's just like the merge of those two. But if you show that commit, it doesn't have the changes in those branches, so I don't know exactly how Git does it. A rebase is different. In a rebase, you don't get this bubble down here. In a rebase, you can imagine, let's try to show it. So if I do, so we're on master now. Let's create some feature branch. Go to the README feature. back to master, go over to the README. I'm basically trying to create a merge conflict. So now I've committed to README, like the same section of the README in both commits. So when I merge, I should get, in both branches. So when I merge, I should get a merge conflict. Git merge. Yep. I have this command vim conflicts that just opens vim with all the files that have these merge conflict markers open. That's just how I do merges. And then I can just look, I probably want both. There's no tricks to actually resolving a nasty merge. Commit. And then we have this merge bubble train track situation that we talked about before. Let's try to do a rebase. Yeah, so this is the commit we want, because that's the one before we merged in our feature branch. Keep this hard. Right, so this is what master looked like before. So basically the issue is that from like the current point of master, we cannot simply merge in the feature branch. If you try to think of these train tracks, you can't simply merge in the feature branch by just moving master forward, because there's a conflict, which means that our feature branch is not sort of a direct child or parent of master. So if you look in the graph, I can see master now. If I go over to the feature branch, I cannot see master. That means that there's stuff on this branch that is not on master. What that means is you cannot do a fast forward merge. That's what Git calls it. You can imagine if I had a branch down here, and I wanted to merge my feature branch, if like master was down here. In fact, let's try that. Go back to master. Go back. So now master is down here, and our other branch is up here. That means if we go back to master, and we merge our feature branch, if you think of it in terms of just commit IDs, in order to merge this branch, all we have to do is move master up here, because like it's a direct child of this commit, and that's what Git will do. So if you look at the branch now, master is up here. There's no conflicts. We can just directly move it forward. That's called a fast forward merge. Now we'll see if we can find it in the ref log. Move feature branch. Where did we reset hard master? Is it this one? This one maybe? Okay. Went to master, check out the feature branch. This is why it's sometimes useful to have those commits.
62 FE.
This one? Yeah, that's where master was before. So now master is there. We cannot see our feature branch, and we cannot see master from our feature branch either. So now if we go back and we do git merge feature branch, we get the conflict. All right. So what git rebase will do is it will sort of set you up to be able to do a fast forward merge. If we go over to our feature branch, keep in mind that what we want is we want to be able to see master from our feature branch. That means that we can avoid having that merge bubble in our commit history. So what if in Git we could undo that one commit that we made, take the commit from master, put that on our feature branch, and then apply the feature commit on top. That's what rebase does. You can imagine that master is sort of down here in the middle. So what if we remove this commit, basically put our feature branch back here. Then we put our master commit on top and put this feature branch commit on top. That's rebase. git rebase master. We get the same conflict that we do before, because remember, the code is the same at the end. So you don't lose conflicts this way. You still have to resolve them. Let's do that. Now you can see my prompt tells me that we're in a rebase. A rebase is sort of a multi-step process. You can imagine that if I had done more than just one commit on my feature branch, let's say I've done 10 commits, I'd have to unroll all those 10 commits, apply the new commits from master, and then one at a time apply the new commits. And that can be a mistake, like a conflict halfway through. Then I have to resolve that conflict and then tell Git to continue applying the new commits. So what you have to do is you have to git add everything, git add all, and you say git rebase continue. And now we're done. So now if you look at the graph, this is the scenario that we want. Our feature branch is directly ahead of master, which means we can do a fast forward merge instead of the bubble. Git merge, feature branch.
So when you do a rebase, you both do git rebase and then you do git merge.
Yes. So if you have a feature branch, you say you rebase master on top of your feature branch, and then you go back to master and merge in your feature branch. I think you can also rebase in the other direction. I never do that, so I'm not exactly sure what happens to the history. But the important part to know about rebase and merge is if you never look at the history, you don't need to care. The code is the same at the end. The only difference is what the graph will look like.
So why would you use rebase?
Personally, I use rebase because I look at the graph and I like this sort of overview. When you merge on GitHub, it'll actually create these feature branches even though it doesn't have to. If it can fast forward, it will create a merge bubble anyway. That's like a setting to git merge. Personally, I think that creates a lot of noise and like lots of unnecessary commits. If I just branch out from master, do 2 quick commits, I just want those back on master. I don't need the noise of the merge. In my opinion, that's not semantic, if you want to call it that. But again, if you never look at the graph, it's not super important. However, understanding the concept of rebase is important because we're going to talk about interactive rebase later, which is really powerful. If you don't know what a rebase is, git rebase interactive makes even less sense. Any questions to rebase? This is usually the tricky part because you're like undoing and moving commits. Also note that when you do a rebase, so this commit ID of the feature branch changes when you do a rebase because its parent changes. So then because of the blockchain, it itself has to change, which means that after you do a rebase, you have to force push. Because the commits are different. The commits that were on origin before are not there anymore. You have to say, trust me, that's fine.
So you cannot do, then can you do rebase on master?
No. Well, maybe. I think it depends on the exact situation and which commits are where. Maybe. Personally, I never do it. I always rebase master onto my feature branches and then merge back. All right. Yeah. Again.
Do you do it always, or do you sometimes just merge?
That depends. If I have, most of the time I do it. If it's just like a small 2-3 commit feature, then I will rebase then merge to avoid all the noise. But if it's a feature branch that has 50, 100 commits on it, then I will merge. Because otherwise, you're likely to get more conflicts. Because remember, merge applies the commits one by one. If there's a conflict that stops, you have to resolve it. Maybe that conflict, when you do the whole merge at once, isn't actually there. It sounds a bit weird, but I have experienced that that is the case. So usually I'll just merge at that point because it's easier. I have a tool, I've written a tool called AG, it's just API Git commands, and it has a tool to merge a feature branch, which will do all the things that we just said. It'll switch, it'll go to master, pull, so we're sure we have the latest master, go to the feature branch, pull, rebase master, push hard, go back to master, merge the feature branch, push master, delete the feature branch locally and on GitHub, push to staging, push to develop, and push to production. And it even supports merging like as many branches as you want, which is a great feeling when you merge 10 branches and it does like 50 Git commands in the terminal. I'm like, great, I didn't have to type that. And it even has some sugar where if one of the steps fails, it'll stop, so you can fix it, and it'll tell you the command to run to continue. So it'll be like, continue from step 15. And that's a little Rust script that I wrote.
You also did it in Ruby before that.
I did it in Ruby before, and there were some subtle bugs with it, so I was like, fuck it, I'm gonna do it in Rust. The fact that it's written in Rust also means that it's much easier for other people to install on their machine, because I can compile a binary for macOS and give it to Thomas, and he can just run it. He doesn't need to install Rust or install Ruby. And installing Ruby is not trivial. You can just get a binary that works, unless you're on Linux. Sorry.
It's not too hard to compile a Rust script anyway.
No.
Rust code.
And this script, I've realized that it's not specific to the API at all, because all it does, it just rebases and merges branches, and it knows to check if the staging branch exists. If it doesn't do anything with it. Same for develop. So I use it on my open source projects as well, because it's just a nice way to get a clean graph and automatically clean up after yourself when you merge. I don't know if you noticed that if you never delete branches from GitHub, 2 years later you have 50 branches on GitHub because you've merged tons of PRs, but you never clean up the branches.
More than 15 things.
More than 50. I don't know how many we have in the API. Probably a lot. Not that many actually.
What about TÜV?
Not from me at least. I just keep on it.
Just cleaned up.
Yeah, because this was not always dealing with all the guys. It's not.
But again, like it doesn't matter. It doesn't take up any extra space because branches are just labeled, so they're just pointers to commits. So the commits are still there. All right, interactive rebase. This is one of those cases where you add a single flag to a Git command and it changes completely. So what an interactive rebase does is it does a rebase, but it lets you control what happens at each step. Let me show you. Have you ever heard of squashing commits? You do that with interactive rebase. So imagine that I had these 2 commits, and I really wish those were just one commit. That's what you can do. So you have to copy the commit ID, and then you say git rebase-i interactive, and the commit sort of before the one you want. So it's like off by 1, if that makes sense.
I always forget that.
I always forget it too.
You normally, what previous company had it in the PR, when you did the merge.
Yeah,
In
exactly.
the PR, you just squash and merge.
Yeah, it's a feature on GitHub now that they do that automatically. This is what they
So it's
do.
the same, okay.
Pecan squash is all the PRs.
I don't squash all my PRs because sometimes like you lose good commit messages in between. If I make a performance patch and I write half a page about why this is necessary, if you do that with Rebase and you're not careful, that might go away.
No, the squash commit contains all the commit messages that it squashed. At least the headlines.
You can customize that. So people might remember.
I think GitHub does that also maybe with a feature.
I think you can customize it, but yeah, by default I do.
Yeah, by default.
All right, so I took a commit a bit further down, just so we can see what happens. So these are all the commits that Git would basically, after unwinding, it would apply all these one by one. And then there's a great little UI here where you can tell Git what you want it to do. If you don't use Vim and you use another editor, I don't know what this looks like. I don't know if you configure your terminal to use Atom, if it then pops up Atom. I'm not quite sure. There is a shell variable called editor that you can configure, and Git and other tools looks at this. So I know that you can tell it to use Atom, but I'm not quite sure how that works. But if you get stuck inside of Vim, just let me know and I'll help you get out. So there's a nice little help here. If you write pick, it'll use the commit, reword, you can use the commit but edit the message, edit, use commit but stop for amending, so you can change the content of the commit. Squash, use commit but meld into previous commit. So that's one commit up, sort of up in the chain here. Exec, all the others I never use. Fixup is nice, but Fixup does the same as squash, but doesn't let you change the message. So what we want is we want these two commits to be the same. That means I need to change this guy to squash, because then it'll merge this commit into this one. And now if we save, Git does something weird. What the hell is that? Cherry pick is now empty. Possibly due to conflict resolution. I'm not sure what happened. It told me that there was like an empty commit, and that didn't work. I think it's because we maybe rebased over a merge commit. I'm not entirely sure. But I did git rebase continue, and it popped this up. So this is sort of like the view that you see in GitHub, where you can see the message from each commit, and then you can tailor that, sort of squash the message if you want. So let's say that we just want this one. Now we save, now we look at the graph. Now there's only one commit. So we used to have two, now there's only one. And imagine, and also notice that we can't see master anymore, because master is now not directly behind us, because we've changed history, basically. So that is interactive rebase. Let's undo that. Let's go back here. Oh, that's not what I wanted at all. And check out. That's the one. This is the one. Whoop. Yeah, so now we have the two separate commits again. So even if you rebase interactive, nothing happens. Let's take this one instead. That way we get the same view. Rebase interactive. So only two commits. I also often use F, which is just Fixup. That does the same as squash, but it doesn't give us that view to edit the commit message, so it just uses this one. I use this often when I have to like squash a bunch of like lint commits instead of amending. So was it you who asked if you can like amend previous commits? That was you. This is what you can do to do that basically. You can reorder commits if you want to. Sometimes I'm working on sort of two things. I implement feature A, or like change A, and then change B, and then I notice that something's missing on A. Then I'll do a new commit, I'll move it back, and squash it with A. So that it's not in the history A, B, A, but it's just A, B. But again, if you never look at the graph, it doesn't really matter. Personally, I like that.
But you still can't do it on old commits, right? Still have to be on the newest commit to do this, right?
No, you can do it on all commits. If you push the commits, then you'll get in trouble, because the commit IDs change.
Yeah, okay, that's
So only do it on feature branches that you work on, and then you'll have to force push. So now we did the interactive rebase, and notice there was no UI to edit the commit message. And now it just uses the message from master, and master is now gone. Now we should be able to get rebase master. And now they're in the same place because, well, they're the same commit. And then if we go back, usually I have lots of branches, and I've written a small tool that will list all the branches, and then it has like fuzzy search to search for branches. This is super nice when you have lots of branches. So if we merge a feature branch, sorry, that's interactive rebase. If you can sort of wrap your head around rebase and then basically say, I just want to customize what happens at each step, it's mostly used for squashing, then that's what you want. And again, if you fuck up, the ref log is there, or you can just scroll up in your terminal as you see me doing. Okay, I have totally fucked up master now. Let's just get it back. Oh. shell aliases. We've already talked about those. If you want to hear specifically how to do it, ask me later. You can also look it up online. Git diff is a cool command. If we make a change in the README, git diff, it shows the change. If I add all files and git diff, it doesn't show me anything. Thank you, Git. To do git diff cached. I don't know why. You can see the changes that you have.
Remove the files into the staging area.
Yeah, on stage or.
Yeah, but currently they are staged.
Yeah, but you just reset it.
Yeah, if you do git reset without hard, it undoes the staging of files and changes that you made, which is also not obvious at all.
How you do git diff? It's the
Yes.
yes.
But that cache thing is a nice one. Actually,
Git add-p. Has anyone seen this? It is really cool. Have you ever made several changes and you wish that you could make those in separate commits instead of all in one? Like I made some changes over here and some changes over here accidentally at the same time. And it makes sense for those to be two different commits. That's what git add-p does. So let's open the README and make some changes in different places. Let's also open user and include really fast. All right, so we've made several changes.
check.
We've even made a typo. If you do git add everything, it just adds everything. It's not what we want. If you do git add -p, p means patch. Now you get this nice UI where you can choose each change that you made. Do you want to include that in the commit or do you not want to include it in the commit? You can do, I believe it's question mark to get help. Yes, stage this punk. Again, Git's terminology is not always helpful. That just means take this thing and include it in the commit. So if I say, yes, I want that one. No, I don't want that one. Yes, I want that one. So now if you look, you can see that all the changes that I made to the user model are staged. And I have changes to README that are both staged and some that are not staged. So if I look at git diff, I can see the bottom thing. So this is not staged. If I look at git diff cached, I can see the change that I made in the top.
That's really cool.
And then I can commit.
Is this the same as VS Code's built-in thing where you get the pluses?
This is how what it works like with under the code base.
I'm just trying to visualize the visual side that I've seen today.
Yeah.
So,
You know use the terminal, git terminal.
no, I did a lot, but there's a very fast GUI that you could use as well.
I promise you, terminal
It's
aliases
very fast.
is much faster.
And it's much faster fun.
Sometimes you're like, what happened? Fuck! I typed the wrong command.
Exactly.
I've never force pushed by accident, I think.
You've never force pushed by accident.
No, never the master. I don't remember having done that.
He always intends to force push.
When I force push, I intend to force push. No matter what force push.
Yeah, so now we just made a commit. GC is git commit. And you can see the change that we made to the README down here is still there.
Just to try to.
Now we can commit that as well. Do that.
So this is limited by Git's definition of hunk.
No.
What if you have
You can say, I believe, many. I believe you can say S. Yeah, so if you type S, that's for some reason not in the hints here. I have no idea why. So if you say S, it'll try to split it into smaller hunks. Usually it does that based on empty lines. If you want to super customize it, you can say E, and then you can really tell it which lines you want and which you don't. I'm not quite sure how to do it because I do it very rarely. Did it right. So yes, you can customize it down to individual lines. Which is pretty cool.
Good.
Good stuff. Git bisect. Anyone who's heard of Git bisect? So Git bisect is mind-blowing. Imagine that you're on master. This used to happen a lot when our previous CTO would commit to the code base. Imagine that you're on master and suddenly the tests are failing. And you're like, what? Why are they? The tests on master should never fail. And you're like, I bet Christian Plank made a commit and he forgot to run the test. That happened a lot. And then like I go one commit back and they still fail. I go one back, they still fail. I'm like, when did they begin failing? That's what Git bisect can do. I unfortunately did not prepare a great example. What Git bisect can do is it can use binary search to search through your history to find out when something started happening. So if you know that on this commit the test failed, if you go back 100 commits, they don't fail. So at some point in between those, they started failing. So you say git bisect start, and then it starts it, and then you say git bisect bad, which means the commit that you're on now is a bad one. The tests are failing, the build is failing, whatever. You go 100 commits back with reset hard. You say git bisect good. And this is the good commits. Now you have the good and the bad. And then I believe you either say git bisect start or it happens automatically. Then it like jumps to the commit in the middle. And then you have to tell it, is this commit good or bad? And then it'll do binary search from that point on until it finds the one in the middle. That's like, this here it goes from good to bad. And the superpower is you can give it a command to run. So you can say, this is how you run the tests. And then it'll do like the binary searching automatically using the command to give you the commit.
How does it know whether it's good or bad?
Based on the exit code from the command. So if the command fails, then it's a bad commit. If the command passes, it's a good commit.
I remember it now. As you mentioned it, I remember.
Yeah, so the middle, and then it gets that next middle, and then it gets that next.
The Git documentation is a bit wordy and uses lots of Git terminology, but to sort of figure out at least the basics, it's good. There's usually also videos on YouTube of people doing it and explaining how it works. I use this like once a month maybe. It's a cool tool.
Is that how often Christian Plank committed to Git?
It happened a few times.
One of them.
Git cherry pick. So let's say that do we have our feature branch? Go into the user and let's make it really fast again. Imagine that I had like done a whole bunch of work on this branch. No, actually, a good example. Sometimes, so we run linting on all files that changes. So imagine that if we unfortunately didn't start using a linter in the API from day one. We introduced it like a year later, which means that if we were to run it on all files, there would be a gazillion changes. You don't want to fix all of them. So we sort of started using what's called like the Boy Scout rule. So when you touch a file, you leave it a bit nicer than you found it. Which means that whenever you change a file, we just use Git to find all the files that have changed between the feature branch and master and run the linting just on those files. That means sometimes we notice like a lint break thing, whatever, in a file that's sort of unrelated to the feature that we're working on, and we really just want to get that one commit onto master, such that I can like push it and Henrik and Justin can use that, and they don't have to fix that thing themselves either. But it might also be a week away from me being able to merge my feature branch. So it's a bit annoying to have to wait a week to get that one small fix included. That's what Git cherry pick does. So if you copy a commit ID and you go over to master, Git cherry pick basically takes the changes in one commit and just applies that on where you are now. So you can sort of pick just one commit. And now that commit that we just made, improves speed. It's with a different ID, of course, because the parents are different, but it has the same changes. So Git cherry pick sort of allows you to just get a single commit. You can also do ranges if you want. Usually I just do it with one commit.
How did you implement that you only lint everything that's been changed since some date? on it.
It's some Ruby script that I wrote like years ago.
Okay.
Nice rich smell.
Can you open
Files,
the
change, since push. Some git diff name only master. Okay. So does that mean that if we move over the feature branch, git diff only master? Those are the files that have changed since master. That's really good.
Git revert?
Git revert?
Yeah.
Ah, yeah. The secret to getting lots of commit in a code base is to make mistakes and then revert them, because that's one additional commit. So all Git tracks, I believe, it just tracks the changes, which means that it can very easily figure out how to undo a commit by just reverting it. And imagine that if you like push something to master, which means you can't just reset hard to the commit before and then force push, because you should not force push master. So I can just say git revert on a commit, and it makes like opposite diff, basically. So now it's gone. If you open up user, user is no longer really fast.
Can I see the?
It just says revert and then the previous commit message. So you can basically double your commit count by doing this. There's
How many commits did you have on the API?
Huh?
How many commits do you have on the API?
I don't know, quite a lot.
14,000?
I rarely use the charts in Git to calculate your salaries, but
We have 14,000 total.
Okay.
Can
We
we
can
use,
we can get that by summer.
10 contributors?
Dave, can you also go through stashing?
Ah, yeah, yeah. So, I had some command like years ago to show me how many commits I've made. I don't remember what it is. Let's give GitHub some time. I think I have a bit less than half of the commits. I think Henrik and I have about the same amount. Maybe I have a bit more. I'm not sure. I think you actually have more additions and deletions than me because you've accidentally committed a log file more often than I have done. Sometimes you see, this commit is 10,000 lines. Why is that? It's because we accidentally committed a log file. That happens.
Have we had some cleanup?
6,000,
files?
4,800. Asbjørn, almost 200. Whoa. You still have more commits than Justin.
Gotta get going.
I love that Engberg, our previous mobile lead, has like one commit. And I think it's, of course, an emoji-related commit. We really like it. Yeah. All right, stashing. So, what's the cell for it? The idea of stashing is that if you've made some changes and you want to like undo those changes, do something else, and then go back to what you were working on. That's usually how I use it. Let's go into the user. And let's say really fast again. And I'm working on user and I'm on team as well. And I noticed that there's something on team that's just horribly broken and I need to fix it right now. I can commit my sort of work in progress work on the user and then fix the stuff on the team and then use interactive rebase to reshuffle the commits to an order that makes sense. If you don't want to do that, you can do git stash. So notice that now we have the change in the user model. You do git stash, it undoes those changes, they're now gone. So I can now do whatever I want. I can go back to master, and I can say git stash pop or apply, and it just brings them, is it branch specific? Yeah. Apparently you have a stash for each branch. Usually I do it within branches. So let's say we git stash, go over to the team, we say fix, committed, fix team, git stash, Pub. Now we can go back to working on the user stuff.
This is usually how I know that I've been interrupting something. If, oh, let me just slash this. That means, yeah, okay, so I'm sorry, but
So apply, is that an alias for pub?
I think so.
Or,
Isn't that the real next steps? It is apply.
You can say they're the same. You can do
They're the
both.
same, okay.
You can also do stuff with like multiple stashes, and you can push and pop from different ones. Every time I do that, I make mistakes, so I usually just have the one.
sounds
Is Stash actually stashed online or locally?
Locally.
Yeah.
Anything else? Anyone else who has like cool Git tips that they do? I'm just looking through my aliases.
How big are the Git files? Are the Git folder on the API?
I don't know.
That's the code.
I think Git is pretty good at like keeping it tight. 200 megs.
And how big is the API?
That has like log files and stuff like that in it as well. It's pretty big.
To me, that's magic. That Git contains so much information. Like it contains a million versions of the code.
Yeah, like we
And
can
it takes up
go back to
multiples.
master. Can you do? I believe there's a command called git rev list. All. So this should be, that's the latest. Reverse. Is that the first command? What I'm trying to get at is, if you want to, you can reset your project back to the very first commit.
Yes.
All that history is there, including all the branches that you made but didn't merge. It's all there. Git has some settings for when it garbage collects stuff, but by default, I think it's like 6 months if you use old stuff. So you have to really want something to go away in order for Git to go away. And as long as there's like a branch that points to it, or it's in the ref log or anywhere, it's not going away. So there's a lot of magic there. I think those are most of the things that I use day by day. And again, like the aliases is just a superpower, because then you don't have to type git all the time. I also have it configured, like if I do G, it does git status, but if I type stuff afterwards, it's as if I had typed git.
Your Git status was different from my Git status.
I might have customized it. Git config. Yeah, SB. I don't know what that is. That's what I do. I think it's like a short range, short status.
Is there a size limit to the Git like file? No.
It's just a folder in your
Every
machine.
6 months it starts. Does it garbage?
Yeah, but like it's very conservative in what it removes.
Okay.
Yeah, that's also why like if you clone like the Rails repo, it takes like a minute-ish to clone that because there's a lot of history that has to pull down. You can like tell it how much to pull to make it a bit faster. But yeah. Any other questions? Anything about it?
We use Git flow on Android, you know.
Ah, yeah. That's a discussion that I have a lot with Engberg. So Git flow is just a branching and merging model on top of Git. You can do it yourself with like git branch and merge and all those normal commands. There's a tool that you can download called Git Flow, so you can do like Git Flow start a feature and finish a feature, and it will manage all that for you. I find Git Flow sort of offensive on like a personal level, because to me it's almost like you don't understand Git. Let me build this tool on top of Git such that you don't make mistakes. I get that's not what it is, and there is benefits to it, especially if you do mobile development. Personally, I find it way too much process. I just rather use Git myself. So the branching model that we use on the API is we merge from master, and we branch out from master and merge back into master. We don't have, like, we do have a develop branch, but we don't merge between, like, we don't merge staging into master, for example. So when we want something on the staging servers, we just merge our branch into staging and push staging, the staging branch to staging on Heroku. And that means that sometimes there's a lot of stuff on staging that's not on master, like they haven't been synced in a while. Then we do that thing I alluded to before, where we delete the staging branch and just create a new one from master and force push that to Heroku. And we do that usually after every sprint, every other sprint. And that's sort of the least process that we've been able to find that works for us. And I would never use like a GUI for Git, because it's like I just want to do it myself. I just want to use it directly. I find that the GUIs are almost making things seem too easy, and sort of hiding things from you that like you don't need to learn this because it's really hard. But it's not that hard. It's just commits. Like it's not that bad.
But if you were forced to use a UI, which one would you use?
I've never used any, so I honestly don't know.
Git Kraken's pretty cool.
But there's so many, and like Engberg used Source Tree, and he said that was the best one, and it used all the others. So Git on the command line is pretty good. So I'm just gonna use that. That also means that stuff like making scripts is just like natural to me, because like I just invoke the Git on the command line, and that's what I always use. Automating stuff in the UI is often not possible. You have to wait for the maintainers to add a feature for you. Like the Git script thing that I wrote that does like 50 Git commands, that's something that you can build because you're comfortable with the command line. Cool. I have been recording this whole talk. Hopefully the recording has worked. I have a YouTube channel where I have done like live coding streams on Twitch, like Rust open source work. There's some videos there. This talk is also going to go up there. If you search for this on YouTube, it pops up. Otherwise, I'm going to share a link later. This is the link to my channel. I don't have enough subscribers to get a cool channel name yet. This is a short URL if you want to use that. This is the long one for when Bitly eventually goes out of service. Yeah, that's good. Thank you. Bye.
If you do want to join the dark side with a